we're going to look at rewriting equations into different forms. So if you look at number 1 on this sheet, your directions are to write the slope-intercept form of the equation of each line. First of all, you need to know what slope-intercept form even looks like. What's slope-intercept form look like? That's y equals mx plus b, correct. Y equals mx plus b. So really what I need is y all by itself, and the x term first, and then b is just some number on the end. So this one right here, number 1, is kind of close to that. It's just that I need y all by itself. So what do I have to do to get there? Divide by 5. Now when you divide by 5, you divide everybody by 5. Everybody gets divided by 5. So now I'm left with just y. I can't divide, 3 doesn't divide by 5 nicely, so we just leave it as a fraction. But then 15 divided by 5 is just 3. That is now in slope-intercept form. I have the slope right here, and I have the y-intercept here. I'm done. Unfortunately, some of them require a little bit more work, like number 2. I want to rewrite this so that it looks like y equals mx plus b, so I need to get the y by itself. What might you do first?
Add 4 to the other.
I would add 4 to the other side first. Then divide by 8. And again, when you divide, everybody's going to get divided by 8. Careful. 4 divided by 8 is not 2, it's 1/2. So there's my answer that time. Does that make sense? Okay, let's jump to one that's tricky. Like, oh gosh, what are you going to do on 8? It looks terrible. Oh, but alas, we have skills that help us with this. What skill are you going to use? You can. But I think that me personally, I would do something in step 1 that would make my life a bit easier. Taylor? I would clear all the fractions. They may come back later, but at least I won't have to deal with them. So what could I do to get rid of all the fractions all at once? Do you remember? Go ahead, Ellie. I'm going to multiply by the common denominator. What would the common denominator be? 20. So I'll multiply everybody by 20, and that will clear all my fractions all at once. What's the, well, okay, that doesn't really matter. So I'm going to multiply everybody by 20. Every single term. Do you remember doing this? Yeah. Okay, so obviously 20 times 1 is just 20. That's easy. But then when you do 20 times a negative 1/4, obviously it's going to be negative, but how do you do 20 times 1/4? Do you remember? You divide by the denominator, multiply by the numerator. So 20 divided by 4 is 5, times 1 is just 5. So that's just 5y. So then 20 times 9/20 x is really just 9x, right? You gotta leave that x there. Now, okay, now it's a lot. Now it's just like number 2, and I know how to handle it now. I just want to get y by itself. But see how clearing the fractions, now I don't have to deal with them anymore. It's so much better. So what would you do next? I would subtract 20, correct. Watch your signs, right? That 5y is still negative. So you have negative 5y equals 9x minus 20, and then all you have to do is divide by negative 5. And just make sure you divide everybody by negative 5. Did you get what I got? Let me ask you about this. See how when I divided by -5, I had 9 divided by -5. But then when I wrote my answer, I put it up here. Can I do that? Yes. If you have a negative in a fraction, you get to put it wherever you want. If it's downstairs, you can move it upstairs. If it's out in front, you can move it upstairs. I always put it upstairs. It's so much easier to work with it if it's just in the numerator. Great. So there's my answer. Well, that was easy. Yeah.
When we go to graph these kind of equations, how does having the negative in the numerator work? Isn't it like rise over run and you're supposed to go up or down a certain number and then over? How do you know whether to go left or right when you're going over if the denominator's sign has changed?
That's why that's a good question. I always make sure that my denominator is positive, so I always go to the right.
Okay.
The negative will just tell me to go up or down on top. Okay. So if you hit one like number 10, this one, I take that back. I said before none of them were horizontal or vertical. This one is. So if you wanted to get this, you can't really get it into slope-intercept form. The best you can do is get y by itself. So wouldn't you just get y equals -5? If I just added the y back over to the other side? That's all you can do here. That's it. That's it for 10. All right, so does that make sense? Going from some random form into slope-intercept form? Now, we'll see. I have this new one. Did you see how fancy this one is? It has the light and everything. We'll see if it can just let me do a long video. I don't know. We'll see what happens. If you look at the next section, now they're asking for specifically standard form with integral coefficients. Remember we mentioned what the heck that was yesterday. What does that even mean? First, what's standard form? What's that look like? Yes, by equals c. Now, what's this business with integral coefficients? What does that mean again? That's it. It's just fancy language. A, B, and C are integers. And if you forgot what an integer is, it's just a whole number or it's negative.
And if you come out with fractions, you have to change it to the whole number.
Exactly.
Multiply it.
So basically, you can't have any decimals or fractions. And if you do, you have to multiply by something to get rid of them. So if you have fractions, you're going to do just like we did in number 8. Clear the fractions. Just multiply by whatever that common denominator is, and then they'll all go away. And then I did mention to you yesterday, oftentimes you are required to have a be a positive number. So if a were negative, you could just multiply everybody by -1, and then we'd all switch. I don't personally care, but it's not a bad habit to get into, because that's how you're going to see it later on. So let's just say we were going to do something like number, I'm trying to find a good one to start with. I guess 11. Okay, we'll start there. So 11. See how in standard form I have x and y together on the left-hand side, and then I have just some number on the right-hand side. So I want x and y both to be on the left. Well, y is already on the left, but x is over here. So the first thing I might do is add 5x to this side. If you want to take this 5 and move it over here at the same time, that's okay to save yourself some steps. So I'm going to add 5x to both sides so that x and y will both be on the left. And then I'll also minus this 5 so that I get here 5x minus y equals -5. And I'm actually done. I don't have any decimals or fractions, and a is positive, so I'm good to go. It's just a number. A, B, and C are just numbers. So in this case, A is 5, B is -1, and C is -5. Okay, so let's try one that has some fractions in it. Let's go to 13. All right, so the first thing that I personally would do is get rid of all the fractions. How?
Multiply by 7.
Yes, I'm going to multiply everybody by 7. Everybody. That means this, this, and this. Everybody gets multiplied by 7. So the first number here is going to be what? What's 7 times negative 25 over 7?
150 divided by 7.
You're doing too much work.
What?
Too much work. Divide first. 7 divided by 7 is just 1 times the numerator. Isn't it just that? Equals 7 times x is just 7x. 7 times 5/7 is just too much work. Divide first. 7 divided by 7 is 1 times 5 is 5. Ooh, so I'm almost in standard form. What do I have to do?
I'll just switch everything around.
Yeah, I would just put the equals negative 25 over on this side. Right? Equals negative 25. I'll just scribble it out over here. Now I'm done. Well, that wasn't so bad. Let's try 15. What am I going to do first? You could. I like to get rid of the fractions first. But it doesn't actually matter what you do. Yeah, so we're going to multiply everybody by 4. So go ahead and try that and see if you get the same thing that I get. Did you get the same thing I got? Make sure you're multiplying every single term by 4. Now, yeah, we can minus the 4x to the other side. And now, are you done? For me, yes. You could leave your answer like this, and I'm okay with it. If you're doing a multiple choice test or something and you don't see this as an answer, or if you are specifically told to make sure that your leading coefficient, A, the first number, is positive, what would that look like then?
4x minus 5y equals negative 20.
Yeah, you just got to multiply everything by a negative 1, and they all just switch. So 4x minus 5y equals negative 20. Either one of these are acceptable for me personally, but I need you to know if you're taking multiple choice and you don't see this top one, it's the same thing as this bottom one. Same thing. Does that make sense? Yep.
I can get 5y. Isn't 4 divided by 4 1? Oh, wait.
Yeah. Sure. So if you look at the back, you'll notice that we never ask you to take an equation that's already written and rewrite it in slope-intercept or point-slope form. That would actually be really hard to do, so we don't ask you to do that. But we might ask you, and I do here, here's an equation in point-slope form that I ask you to now write in slope-intercept. Oh. So remember what slope-intercept was, y equals mx plus b. So how are you going to rewrite something like 21 so it looks like this? Really?
First distribute.
Yes, distribute first. And then all you gotta do is minus the 5. Sometimes it's not quite that easy because you have to deal with some fraction action. Let's just look at number 24 real quick. If I was going to do the same thing, so I would operate the same way. First I'd distribute that negative 1/4, and then I'd add the 2 to the other side. It's just you got to deal with fractions this time.
Can you cancel out the fraction?
I mean, you could try. Let's distribute first. So I get a negative 1/4 x plus 3/4. I guess you could if you wanted, yeah. This actually isn't so bad though, because look at where I'm at. In order to get to slope-intercept form, all I have to do is add 2 to the other side. It's not that bad to add 2 and 3/4 together, because what do you get when you add 2 plus 3/4? 2 and 3/4. If it was a more annoying fraction, maybe I would cancel the fraction and then work my way back. But this one's not so bad. If I just add 2 to both sides, I get y equals negative 1/4 x plus 2 and 3/4. I don't care if your y-intercept is a mixed number. That's fine, but you would never give your slope as a mixed number. So far, so good? So then the last one I want to talk about, if you're trying to go from point slope to standard. So let's just let's do number 31 first, and then we'll do one with a fraction. So if I wanted to make this look like standard form, remember, standard form is ax plus by equals c. Ax plus by equals c. So I want x and y together on the left-hand side, and then just a number on the right-hand side. So what would you do first to turn this into standard? I would still distribute. And now it's not so bad. What would you do now? You could. And then, oh, you're in slope-intercept form now. We got to get to standard. Minus 2x. And you could either leave your answer like that, or you could change everybody. Since a is a negative, you can now make it 2x minus y equals positive 5. Same thing. And you know what I'm realizing? These are too easy. Let's do one together where it's more difficult. I'm going to make it up. What if you had y minus 2 equals, oh, I don't know, 1/9 x minus 4. And you had to turn this into standard form. What do you want to do first? Sure, we can distribute first. Now what might you do? You can, but I think there's an easier step first. Because standard form, I'm not allowed to have fractions anyway, right? So let's get rid of them right now. Then I don't have to worry about them anymore. So I would multiply by, what would you say? 9. Everybody gets multiplied by 9. So you do it out and see if you get the same thing that I get. Did you? Oh, good. And now I'm almost there. I end up in standard form. You might now do what?
Do you'd add the 18, sorry.
I'm going to do them both at once. I'm going to minus that x over, and I'm going to add the 18 over. And I'm done. Unless you want a to be positive, then it would just be x minus 9y equals negative 14. Either one. Hooray!